All right, so baking textures and cycles. Not anybody's favorite. We use it because we have to. It does the job. There's no other options except add-ons. But we all wish we could bake in Eevee. Often we don't need all of the stuff Cycles does. If you just want to get some basic colors or some decals or something, why do we have to deal with like render noise in our textures and sampling and all that? But Eevee has no bake system. But with geometry nodes, we're going to build one. The node setup is very simple, and if you've watched my previous videos, this will look very familiar. So my outfit has all been combined into one object for the purposes of this. It's got a UV map, some of which is nice, some of which is, well, whatever. So in our geometry nodes, we have a new object here, and it's got this node group on it, which I'm calling UV canvas. And we are going to input that object. So now we have a copy of it down there. Now we are going to lay this out to its UV map. So we'll get a set position and a geometry named attribute of the UV map and set the position to the UV map. And now it's all X and Y because UV is an X and a Y. So we will grab a vector rotate node on Euler. 90 degrees on X. You don't have to do this. I just do it this way so that I can see things a bit better. And also, I'm going to center this on the origin point. So for that, vector math. And we'll just subtract 0.5. And we'll stick this back over there. Next, we have the problem that our edges are not split where the UV seams are. So in the UV editor, if we don't already have seams set up for whatever reason, we would select everything and use seams from islands. Then in geometry nodes, we want to input those and split edges. We can just split the entire mesh with the edge split node, but it's actually really slow. 1.8 milliseconds is slow. So we want to get another attribute and input our seams, except they aren't there. The seams attribute is not actually implemented in GeoNodes, at least not in Blender 4.0. Maybe it'll be in a later version by the time you watch this, but for now, we need to use a different edge attribute. So I'm going to come here and do a Shift-G, select all the seams, and I'm going to mark the bevel weight. Well, I already have it done. You could also use Creature Sharp, but I'm not using any bevel, and I might use Subsurf. So back here, we can now get that bevel weight edge and split based on that. So that's doing the same thing now, except it's much faster than before, because it's only splitting edges that need it. Okay, next problem. Some of these edges look weird, and that is actually because the mesh has been doubled up because I'm using the mirror modifier. If I turn it off, the problem goes away. If my UV map was mirrored, if it only took half the space and I was using mirror U, I wouldn't have this problem. If I compress this in here, now it's fine. I need to split it across the center. But since I am using a mirrored UV map, I need to resolve this issue. I could just turn the mirror modifier off, but I don't want to. I want this to handle things for me automatically, because the point of this is convenience. So what I'm going to do is have the nodes delete the half of the mesh that I don't need. So that's deleting everything right now. We need to make a mask of only the right area. So we'll get the position attribute and split, separate XYZ. And now, that's that node. Now we can look at only the X of the mesh in world space. And we'll get a compare node and get less than 0, and now we have a mask of the mirrored side of the mesh. So we will plug that in, and now, problem solved, we have deleted the unnecessary part of the mesh. But that's not something we always want, and it does cost us some time, so let's make that optional with a switch node. When true, it will do that, and when false, it will keep the original mesh. And now let's get a group input and plug some of this stuff in. Put that switch in and have it delete mirrored, but set it to not be on by default. So now in the modifier itself, we can adjust this. And while we're here, let's plug in some of these others because we only want to have to build this once. So that's our seams and that's the UV map. So now we can select all those in the modifier. And I suppose we should let ourselves select the target object as well. And these days we drag and drop these. Now something to watch out for here is once we've done that, we want to set this to not default to anything. Otherwise, oh, and also delete that from here. Otherwise, Blender will keep a link to the target object and drag that into any file you append this group into. So we only have to do that for the object though. Since we're here, we should also plug these into the input so that we can control the whole transformation. And let's get ourselves a set material. We'll add that to an input as well, because we don't necessarily want the same material as we have on the incoming mesh. We're going to overwrite the whole material. And again, I haven't set any default on that so that it doesn't link that in. And now our group is done, I think. The last thing we need for our bake setup is a orthographic camera. So we get a camera, we will set it to the same position as this, move it forward on Y a bit. It doesn't matter where it is on Y, as long as it's not at 0 or negative. And I'll make it the active camera with Control Numpad 0, so now we're looking through it. We will set it to orthographic, and now the size should be 1. That means it's 1 Blender unit by 1 Blender unit, which is exactly our UV space. I'll name it Bake Camera, and I'm going to parent it to this UV canvas. So now if I move that around, it moves with it. And now I can just hide it. Okay, our render bake setup is done. Now we just need something to bake. I've given the UV canvas and its texture canvas material a ghastly shade of yellow-green, or at least that's what it looks like to me, but I'm colorblind. And, well, that's the UV map, and we've put it solid color, so we just need to render it now. There we go, solid color texture. We are rendering with transparent film, so the background isn't filled in, but we can head over to the compositor and turn on the backdrop. And now if we want to change the background color, we can do it here with an alpha over. Add a viewer note to that. So there we go, whatever background color you like. Or you could do something like put some other geometry behind it or change the world color, change it off transparent. I find it easiest to adjust here, but that's really up to you. Now we could save this out from the render view here. If I picked render result and did Alt S and pick our various options, but I am going to set up a file output node instead so that it will automatically resave as we make changes, because that's kind of the point here. So we'll target our default textures folder, and we'll use a 16-bit RGB PNG. And now I will hit F12 to render again. And there it is. Didn't put a name on it. Let's give it a name. Let's call it, yes, good to end with these with an underscore, because it's going to append the frame name. There we go. Now we can bounce back to shading, and over on our main material, which is awaiting the texture, we'll select that, and there it is. There's our texture. And if we come over here and say change the color, and then hit F12, done, come back over here, I'm going to use the Node Wrangler add-on to do a quick reload images. It's updated. So that's neat. We can change the color and update quickly, but that's not enough to justify all this setup. So what else can we do with this? Well, I prepared some examples over here. For example, here is some text, and this is just superimposed over this object. So when we look through our orthographic camera, whatever we see here will be our texture. So let's hit render. And now reload images. There's the text. Let's check out what else I've got. How about a Bezier curve with a procedural texture on it? This is just a wave texture. This curve is just, again, superimposed in front. You want to use a procedural texture and get it on some part of your mesh. Well, there it is. I mean, you probably shouldn't make that exactly, but it's a cool example. How about some grease pencil? Here is Suzanne. And I've even got a grease pencil glow on it, which you can't really see on this yellow. Let's make that something less awful. All right, that's pretty cool. Normally you can't make grease pencil, but we can. Yeah, that's cool. And of course, time for the shameless self-promotion. That's right. Now, how about something more complicated like a normal map? Well, before we do those, we need to talk about this other issue here. You may notice we have some dark lines, and that is because we are missing seam margins. Margins are a normal part of any big system. I'm going to turn this back to an offensive color, forgive me. So normally in cycles, the margins are something you choose down here, where you use extend as the regular one, adjacent faces as a fancy new one, but you don't normally need it. But this closes these UV seam gaps, so we need to make an equivalent of that too, and we can do that. Okay, back to a horrible color so we can see this part more easily. We have the in-paint node. And if you watch that border here, you can see as I turn this up, it is dilating those borders out. This is the same margin function. And it does this based off the alpha. But you may be noticing that that margin it's creating isn't quite the same color. And if you're not, I will zoom in a bit so you can really see it. It's not the same color, so it's not actually going to solve our bleed problems. And this is because of the way in-paint works, is as it dilates things out, since it's based on the alpha mask, it inherits the alpha mask's problem of being aliased at the edge. This is pretty hard to see here, but it's actually the alpha mask has that problem in it already, and it's inheriting it. So we need to fix that. And the way we're going to do that is with the dilate and erode node, which lets us also dilate things out, or in this case, we're going to chop 1 pixel off. Now to have the in-paint use this, we need to correct the current alpha. So we'll get a set alpha node and replace the alpha with the dilated one. And then we run that into in-paint, and that earlier problem is gone. Everything is the same color now. So now we have margins. Let's render that. Update. And those margin lines are gone. Okay, so we've covered flat colors, decals, superimposing stuff. What if we want just its own mesh data? Let's make ourselves, say, a vertex color. Blah. Now, if we want to render this, well, this mesh is inputting this mesh. So anything on here is on here. So here we've got the vertex color in there, attribute. Let's call that. And now we can just use the attribute in here. There it is. And now we could render that. Now, what about something like if we wanted to render shading or normals? If we get the geometry node and get our normals here, well, this is giving us the normals of this mesh, not of this mesh. So we can't bake those easily, but we can still get them. We can get anything that we have access to in geometry nodes. So all we're going to do here is all the way at the start, before we delete anything, well, it could be before or after, depending on what you want to do, but all the way at the beginning, we will get a store named attribute node. And in this case, if we want the normals, then that's going to be a vector. Presumably we want them interpolated. So leave it on point, gn normal. And now when we go to our shading, once again, we grab the attribute node, and there's our normals. And this is being saved before we split the edges, so this will still be the same normals of the mesh. They're not affected by the split. But of course, if you had something like auto smooth turned on, then you would need to remake this in geometry nodes, which is a default coming in 4.1, so don't worry too much about that. And because we have normals, we can do some stuff like bake shading if we wanted to. So like here's a diffuse, and currently we're not getting anything because our normal is just a flat plane. But if we plug these in, now we have light. I've got a sun lamp up here. So this is actually shading the same way the model would, because, well, normals are normals. We do actually want a vector math normalize here to fix some vertex level interpolation issues. But with that, now we can hit render, and there's bake shading, except it's mirrored, so this isn't a good example for, a mirrored mesh. But you can technically bake light with this if you want to. It's just not going to be the greatest. I wouldn't bother with this, but yeah. Another use case might be something like if you wanted to bake ambient occlusion. That's also not going to work because it's using the world space position of the mesh. Like, I can plug in normals for this, but it doesn't use them in the same way. So you do have to have the real mesh for that. Although I guess technically you can build ambient occlusion in GeoNodes, but then it's not pixel based, so you'd have to use a lot of subdiv on the mesh. And well, you can bake any GeoNodes based effect, but you're not going to get everything the shader does. Okay, so we can't do every single thing you might want to bake, but what about normal maps? That's the other major thing you bake all the time. I've got some examples of those too. So here is a normal decal. We'll see how that works. If you've watched any of my previous videos on normal mapping, you'll be familiar with these groups. We can bake normals, but we have to do the tangent normal map calculation ourselves. So what we've got here is a crumpled plane, since this is just an example. There's just regular normals. Now we get the tangent normal difference of it and a flat plane, which is just a normal of y, and a tangent of 1 on x, which is that direction. And now we can render bake this, but we're going to need to make some adjustments to the rest of the material, or this won't look very good. Like, let's set the color of everything else to this, and let's hide all of our other decals. And also in compositing, I'm going to make a few changes. I'm actually going to make this a second texture output on our output node here. So we'll do... And it is very important that we uncheck Save as Render, because that applies the sRGB transform, and that means that it won't work as non-color data. So I messed up the backdrop during the skip, but now we can do that, and there's our normal decal. And back over in shading, I'm going to move to these nodes I have set down here already, and make sure that's on non-color data. And there is our normal map. Sun around, we can see that there. So that is a functional normal map decal. And this is an area where this technique really shines, because normal map decals are usually a giant hassle to do. Let's make another one. Here's a clean shape, so this should be a good test too. There we go. It's that easy. In cycles baking, if you're trying to bake from like a torus to this surface, it's just a giant hassle to do. So any variant of this method where you bake something flat and then project, it's much easier here. But of course, this is all only as good as your UV map. And now if you've watched my previous videos and wondered why I like to do these evenly spaced grid UV maps, it's so I can do stuff like this. Of course, there are ways to have, say, a world space version of this torus and unwrap it to a flat version, and then do these projections. And we'll probably get to those in a future video, because that stuff is also fun. And another thing this technique allows that you can't normally do easily in cycles is baking normals to itself. Like say you had a mesh and you did a bunch of custom normals in geometry nodes like I talk about in my previous videos. Well, those would be a GeoNodes attribute, and then you could just do what I showed earlier and store them and then just bake them like this. And well, in Cycles, you have to put those in and then bake them as a color, and then it like makes them noisy for no reason unless you use a bunch of samples, and then it's, you know, a bunch of messing around. So the last question is, can we use this method to bake high poly to low poly? And the answer is yes, but it would take me a while to go through it. So I'm going to save that for a future video instead of tripling the length of this one. Thanks for watching. In the next video, I'll probably be showing how to project meshes using a similar method, so you can get mesh decals on the surface, not just textures. So I'll be using both of these to detail this character. So please like and subscribe if you want a notification when that's out.